Dr. Louise Leakey is carrying forward the work of her parents and grandparents, the legendary fossil hunters who have contributed so much to our understanding of our origins. Dr. Leakey is co-director of the Kubifora Research Project in Lake Turkana in Kenya with her mother, Meave. She describes herself as the logistician of the projects there. She's a National Geographic Explorer in residence and a research professor here at Stony Brook University. Dr. Leakey, it's very nice to be able to talk to you.
Thank you very much for having me here.
Tell me a little bit about growing up a Leakey.
Well, we were often at Lake Turkana during our, what you would have called summer holidays, while they were traditionally working up in the field at that time of year. And so we were in the field while they were collecting many of the big discoveries that people know about today. So from aged 6 weeks, I think, I was up at Lake Turkana for the first time. And then subsequent years went up time and time again. Now, we weren't actually out in the exposures doing the fossil work till much later in time, but we spent our childhood running along the lake shore collecting little crocodile teeth, bits of tortoise shell, or whatever we could find. And we really grew up loving the Lake Turkana area and therefore still feel very attached to the region.
You said what we would consider our summer vacation. Were you somewhere else for the rest of the year?
Well, we still had to do our schooling, and so we, of course, had to go back to Nairobi, the capital city, which is about 700 kilometers, what, 400 and something miles away. So we spent a lot of our time in and around Nairobi where we were educated. And then we went up to Lake Turkana when they were doing the field work. We sort of had to fit in to their lifestyle.
You said about 400 miles away, and over, I would imagine, relatively rough terrain.
It is a long way away. You lose the tarmac, the surface, the good surface, the paved road, not too far from Nairobi, and then you're off going across the beaten track. And it's a 3.5-day drive to get to our field sites from Nairobi, or you can fly, which is a 2.5-hour flight in a single-engine aircraft. Now, I learnt to fly an aeroplane for that reason, because it does mean that getting up to the field sites is that much quicker. And, of course, in terms of resupplying and getting people in and out, it makes a lot more sense to do it that way.
What about your schooling? You said you spent your time in Nairobi. What sort of school did you attend? Well,
we were sent to nursery schools initially, and then my younger sister, Samira, and myself were sent off to a convent, a private school, a convent called Loreto Convent Msangari, which is close to Nairobi. We were sent to a convent because somebody had to teach us about religion, and my parents obviously weren't going to do that or felt they couldn't do it effectively, so we were then sent there to go and make our own informed choices about what we wanted to believe in or not believe in.
And how long did you spend in the convent you were sent to?
We spent 6 years there, and then we were actually starting the national curriculum, and that then changed into a new education system. So we then moved out of that back into the traditional British education system that enabled us then, after age 16, to go overseas and slot into the universities outside of Kenya. So we moved school several times.
And eventually earned your PhD.
I got my PhD from London University in 2001. And then, but before that was at Bristol University in Bristol, and I did geology, biology at that point in time.
You had already, because I think you were 12 when your father discovered with others Turkana Boy, a major find. What do you remember about that?
It was a very exciting discovery, of course, because that find was unexpected, and that such a small piece of the skull was found by Kamoya Kimeo on the edge of a riverbank.
He said the size of a matchbook.
That's right. It was tiny, and so it wasn't really expected that anything would come out of this. So when they started to find bits of teeth and more bits of skulls, and then found bits of the ribs and things, and it was obviously going to be a project that was going to take several years of uncovering this fossil. We then, because we were slightly older, could get more involved and be useful in the field rather than just sitting around whinging about the heat. So we were then put to work, and I remember learning how to drive a Land Rover down sand rivers and looking through the steering wheel and the dashboard at the road because I was so small at the time. And we went to collect water from the dry sand rivers with a lot of the local kids that were on holiday and working with us, then singing songs with them, playing games in the sand. We used to take the sieve, the sieving material from the excavation down to the lake shore to wash it and look for small bits of bone. So we were very involved, and it was a terribly exciting time, but also very memorable for myself.
Tell me about collecting water. How do you collect water?
You have about a 30-strong team of people living usually on the edge of these dry sand rivers that drain from the basin margins towards the lake, and they only flood when it rains. I think you'd get similar situations in places like Arizona, desert
Texas,
environments,
yeah,
exactly.
Oklahoma.
So when it rains, you get these flash floods coming down these rivers, and they recharge the water table. And so if you know where to dig on corners, or often using the local people to help show you where these are, you can actually dig down a meter or maybe 2 to 3 meters sometimes and actually get down to that water table. And if you're very careful and you use a cup, you can then scoop up the water and put it into a bucket and then pass the bucket up the hill into a funnel and into the drums that are in the back of a Land Rover, and you can then supply the camp that way. So water is extremely precious, and we've grown up knowing how to shower or to wash with a cup full of water. And it always alarms me in this part of the world, in America particularly, how much water people actually use and
Waste,
don't
yeah.
forget, don't remember to turn a tap off.
And at the same time this was going on, Turkana Boy was being unearthed, and as you say, it was a several-year project to reach the point where that discovery, I suppose, could be announced and documented. And you were at that time growing into your teens.
Mm-hmm.
Was that was the importance of that find something that you were aware of?
Not at the time. I think the importance of it obviously has dawned on me much later in my life, particularly with all these other fossils, because I certainly didn't appreciate how little was known about these fossils until much later, and how young a science it actually is. And when my grandfather set out to work at Olduvai,
Louise Leakey,
they just didn't know the dates of these things, and they didn't know who the makers of stone tools were. They didn't know. There were so many unknowns. There still are many unknowns, but we do have a much more complete picture. Yet if you think about how hard it is for a fossil or a bone to become fossilized, for it to then be found by one of us walking across a land surface, or for it to be exposed, it is remarkable that we know as much as we do. So that is terribly exciting. But I really began to appreciate the significance of these, particularly the Turkana Boy, much later in time.
Turkana Boy was, I believe, 1.6 million.
It's 1.6 million years old, and it was a sub-adult who probably was walking along a swamp and fell in and then couldn't get out. There's some speak of the fact that it had a disability, and that maybe this led to it being submerged. And because it was in a swamp situation, the bones didn't get picked up by carnivores or scavengers, and so they remained in one place, which is very unusual for any of the fossils that we find in Lake Turkana. They're often very fragmentary, and you therefore have to use lots of different specimens to piece together a find that you can then, say, a species that you can then begin to talk about.
In this case, a very large part of the skeleton of the boy was found.
Very large, pretty much most of it, except for the little digits, finger bones and toe bones, and those, of course, being the smallest and the lightest bit, probably moved further away. Now, at some point in time, you have to say, okay, this is the end of an excavation. It's taken 4 consecutive field seasons over 4 years to get here. It's costing so much. You've got to draw the line somewhere. There probably are still in the ground somewhere there, but whether you'd actually find them, it's like looking for a needle in a haystack. Mm-hmm. It's a large area, and it would be quite costly to actually recover the last few bits. You don't know where to look. There's no means of finding out where they are in the ground.
You were also around, I guess, when your mother discovered a flat-faced man. Was that?
It's called Genographic platyops, which is a flat-faced man from Kenya, that's right.
And he was more than 3 million years.
He was about 3.6 million years, and he was found from the west side of Lake Turkana. And it was a year when she was working up in that area. And it was towards the last 2 weeks of the field season when a young man called Justice, who in fact we worked with collecting water from the Nariakotomi site, the Turkana Boy site, he actually found a small bit of that brow ridge and was able to work out that that was important, and they began that excavation. It was quite a difficult find to pick up because it was in this clay that had expanded a lot, and the find doesn't look very pretty, and it took good 9 months to actually clean it up very, very carefully before they could even begin, or before we could even begin to say what it might be and the significance of it. And then you then have to make all these comparisons to many other finds using very expertise in that field. So we bring in a lot of colleagues to work with us on these finds before it can actually be published.
You said that find was made 2 weeks before the
end of the field season.
End of the field season. Did you then have to remain, or did you come back the next season?
No, that find it was picked up, and the idea was there probably wasn't much more of that. Once you'd put in this sieve and it was covering a large area, you had recovered as much of it as you were possibly going to find from there, and so that was the end of the season. But funnily enough, most of these discoveries are always made in the last 2 weeks of any field season.
That's what I was thinking, yeah.
And so maybe one should only do 2 weeks of field
right.
work, but I think it's because at that point in the season you've pretty much done with your field research area, and so you tend to move into a new area. And of course that's when everybody's got their eye trained and they know what they're looking for, and invariably that's when they find things, which is why it'd be nice to have much more of a year-round presence up in that region, because you could then keep people focused, and you would probably then increase your output and your performance.
I think your father said Turkana Boy was found maybe 2 days before they were going to strike camp and go somewhere else, and that they really at the beginning were sort of upset that they now had to stay around just to see what this was they found, but it turned out to be
often
okay.
the case. That's right.
What were you? You say you do a lot of the logistics, and you did describe getting water. What do you do otherwise?
Well, if you think about a field situation where you've got 35 people and you're in an incredibly remote area, they need to sleep in tents, and you've got to have beds, you've got to have food, you've got a staff that have been drawn from the local area. There are always personnel issues. You've got to get supplies in and out from Nairobi because there's nowhere else you can get them from. Water. There's an awful lot that goes on behind the scenes to any expedition, and I've often been in charge and responsible for all of that happening. So flying the aeroplane in and out and making sure all of that works is, again, on my docket.
A single-engine aircraft wouldn't carry very much in the way of supplies, would it?
It's a Cessna 206, which can carry 6 people and a little bit of luggage. So you can actually get quite a lot of supplies in to the field in that, and it's got an extra pod to it, an area that's beneath the main body, so that you can actually load that up. So it's a very suitable aircraft to have in that region, because you can land on these very short strips and you can get a lot of luggage cargo in and out. And
you're running lorries and Land Rovers and such?
We have a big truck that we use to get fuel supplies in and food and tentage. And then we have trucks or four-wheel drive vehicles that can then deal with sand rivers and the rough terrain that we have to deal with every day. So we have to get people from the camp where we're staying out to the field sites every day. So you're usually driving an hour or so every day to get to the location. You have to weigh up whether it's better to camp close to water and drive to the fossil sites, or you camp close to the fossil sites and drive to water. So it doesn't make that much difference, except that we generally stay closer to where the water is, because it means it's that much easier.
You said 35 people typically. What are all these 35 people doing? How do they break down in jobs?
We have people who who cook in the camp, and we have people who oversee all of the camp staff, essentially the tents, and they make sure they don't get blown away, and the firewood needs collecting, and goats need to be caught and slaughtered or bought or to feed the 35 people that are in the area. Then you've got your fossil hunters, and that's obviously the main core of our staff, and they're the people who go out every day armed nowadays with a GPS and a digital camera, and they go and look for the finds, little bits of bone on the surface, and record where they are. We then can download that information and work out where to go each day. So we've got drivers. So it's a huge number of people, each with their own individual roles to play, plus the foreign scientists who possibly join us for shorter periods of time, and my mother, Meave, and myself, and my 2 little girls.
2 little girls. How many fossil hunters are among the 35?
There are about 15 fossil hunters who are actually looking for fossils. And then you've got scientists who deal with a lot of the data entry and processing. And then we have the collection team, so maybe 3 or 4 people that are then collecting a next level of data as you pick the things up.
How would it compare with 20 years ago, when you didn't have access to global positioning satellite information and computers and so forth?
Well, those days, when my father and mother were out working those exposures, they had a smaller team of people, probably 8 to 10, I think, and they used to rough it, and they would move very fast across these areas, finding all the really exciting things on the land surface. Obviously, they picked up a lot of the big and exciting finds then, because nobody had been in those areas before. So it was pristine in the sense that what you found hadn't been seen or picked up. So many of the big discoveries they picked up in those early days, when they raced through, were what the world knows about today. They didn't have the GPS system, so the fossil hunters would mark a find with a small cairn of stones. You put 5 or 6 stones one on top of the other, and then they would point my father and mother to where they'd found anything. They'd have to then charge over to that, have a look at it. If it was good, collect it, recording basic data. But if you remember those early days, they didn't really have the same amount of information on the stratigraphy, the geological context of the finds like we do today. So we are working with 35 years of information behind us, which makes it much, much easier for us to place things on the landscape. So they'd find the things, they would mark them, collect them, and then they would move on to another area. Now we can take a digital image of a find and we can plot it with a GPS, and you can put these things back on a landscape using GIS, Global Information Systems, and you can actually get a much more complete picture of what was going on in the past. And we're beginning now to bring in all that data from the early days into these new systems.
That's interesting. Now I gather a lot of times you don't necessarily bring the finds in. You just mark where they are and sort of map them if they're not important enough to bring in, so that someone at a later time can
That's
go
right.
there.
If we were to bring everything in, we would just never move on. And where do you put all this stuff? And so by recording it with digital imagery and a database, if there is a student out there or a scientist who's interested in pig teeth, he can run through the database, or she can run through the database and actually then say, okay, I can just go there, and go and pick them up if necessary. So we just don't have the manpower to collect everything, and not everything. And, I think it's also quite important to leave some of the material on the land surface to some extent, because people can then see the context in which it was found. And sometimes things aren't, they may be more underneath and fossil areas that you may not have realized. So I think it's still important that some of that material is out there for people to see in context. If it doesn't all necessarily have to be put in little drawers. Where it's safe, mind you, because I should just add that some areas have got increased pressure from livestock populations, and when you have 1,000 hooves go over a fossil site, they can do tremendous damage. So we've actually been collecting in areas where there's an increased human pressure. And so where it's more protected, say in the national park at Sibeloy on the east side, there's less pressure there to pick everything up.
Do those areas change? I mean, if something has been there 1,000,000 years and you're still able to find it, why are you concerned about 1,000 livestock
Because
today where you weren't,
that's right.
you know, yesterday?
The livestock numbers have changed dramatically, and I think that is the difference. There are so many more people in the world, there's so many more people in little centres at Lake Turkana, and they all have livestock, and those livestock numbers on the increase and look for grazing, and they don't care whether there are fossils on the ground or not, and goats don't follow paths. Goats go across anything and make a desert of anything. And so they do a lot of damage.
Are they nomads who move from camp to camp?
That's right. They're pastoralists. They're nomadic, and they do move according to where there's grazing.
In fact, you talked about locals helping with the water recovery efforts. Does that mean you're speaking Swahili to them?
That's right. We speak Swahili, but they all have a local language as well. And we do interact very closely with the locals, not only because we're there, but we work with them. They often are the fossil hunters, and we work with them 5, 10 years, and they then know what they're looking for, and it's those are the people that are getting much more involved in the long-term aspect of this work. They're the people who are beginning to do the preparation, and when we develop the new research centres on the ground on the west side and east side of Turkana, which the buildings are going in now, it's the people from those local communities that will be working year-round to ensure that this continues.
It seems to me that the decision to decide where to look, is that dependent on what age you're looking for, you're interested in, you know where the strata is that is 1.5 million years old and so forth. And I gather some of this stuff in that area is 7 million years, goes back 7 million years.
The Turkana Basin it's a 160-mile long lake. Today, there is a lake there today. In past time, it was a very long, slow meandering river that ran through the basin and did have an outlet. And so the fossil sites, some of them today are underwater, and some of them are further afield. So it's a vast area, and so there's plenty that has to be worked. Sorry, what was you?
Well, do you decide what age you're looking for?
Oh, the age. That's correct. So because over the last 35 years, we've managed to build up a very accurate record of stratigraphy. We know where certain age deposits are in the basin and can actually then, as you say, go to a certain age and look there. But not every area is fossiliferous, and so you still actually have to go in on the ground and check. There may be an area of deposits, but you need to go in on the ground and actually check the age is correct and collect samples for dating and actually find out if the fossils there are from lake beds where you're finding fish and crocodiles, or you're getting terrestrial assemblages. And so you have to go in on foot, and you therefore have to draw on either work that people have done in the past because they've gone in and collected, and you can use maps that they've left. But there are areas that people still haven't been into, and so we still need to cover that ground, and we're doing that today, going back over the entire basin with GPSs and cameras and actually collecting a second layer of data throughout the whole sequence.
You're going to map the entire thing to the best of your ability.
If we can, but it's going to involve an awful lot more people. And so through the Turkana Basin Institute, involving a lot more scientists, a lot more students, graduate students, hopefully this will become a major source of projects and information in the coming years.
And a year-round operation as well.
The hope is it will be year-round. It's very difficult to actually collect and walk across exposures year-round, because when it rains, it turns to mud, and you'll then walk off with the fossils on your feet. So we don't like people to walk across areas when it's wet. But the buildings will be there, and the cleaning will be ongoing, and there's plenty of work to do year-round. You don't have to be collecting all year-round. but there certainly will be work in progress all year round.
You said that some of the fossils are covered in lake water at this point. I suppose they're just unreachable.
You can't get to the things at the bottom of the lake, no. But several hundred years from now, you never know, with changing climate, whether that lake will dry up much faster. But traditionally, it's because it's filled up with the sediment that's come down from the Omo River, and so it takes 100,000 years or so before that lake basin fills up with sediment, and then you get a shift in the tectonics, and something else happens that means that you suddenly have more water coming in or whatever. So in geological time, it will change, but in the very recent time, we are very unlikely to ever be able to find the fossils at the bottom of the lake.
What are you seeing, if anything, that indicates to you that there's global warming or climate change going on?
Today,
yeah.
Certainly the lake levels are dropping, and since my childhood, they've dropped significantly. So there just isn't as much water coming into the lake. Now that does happen in geological time, and you can see that because 12,000 years ago, there was an enormous lake, very, very high levels of water, and the lake went way inland. And that was only 12,000 years ago. So, but day to day, in terms of that lake really has been, the general trend, it has been going down.
That means less rainfall?
It's probably to do with less rainfall and higher evaporation off from the basin.
Which would also, of course, lead to all sorts of other
well, you're getting more
problems.
droughts in the region. And, well, this year we had tremendous amount of rain, which caused a lot of damage. So it's hard to know what's a local effect or it's a sort of long-term effect from that basin per se.
But in an area where water is gold, whether you're getting too much of it or too little of it is a big deal.
That's right, and also there's so many more people living in that area, or as they are anywhere in the world, that natural disasters obviously have that much bigger an impact on people living in these regions, because where there were 10 people, now there are 100, or where there were 100, there were 10,000, and so your disasters and the consequences for people are that much greater.
Why is knowing about our past so important?
Well, it's good to remember in this day and age that we all have a common ancestor, and in this day and age where people are so conscious of religion and colour and where people live in the world, and there's so many wars and fights about things. We come from a common ancestor. We are one species on this planet, and for people to understand that, I think, is highly significant and it must not be forgotten. The fact that there are not many areas from which we can get the evidence to show this is also means it's terribly important to protect this area for global heritage, and so that in a sense is why we do what we do. It's quite difficult to do that in this day and age when there's so many problems with education and with medicine and people struggling for day-to-day survival right on your doorstep. So it seems to be a bit of a luxury to work on fossils, and that's why I tend to spend quite a lot of my energy working with communities and healthcare and education as well.
What are some of the important things that we still need to find out that we don't know? What can you pinpoint one or more of those, a couple of those that you'd really like to know the answer?
Well, from the age bracket that we've traditionally been working in at Lake Turkana, which is really 4 million to 1 million years in more recent times, about 2 million years there were 4 species of hominids living contemporaneously. And we still don't have fantastic specimens for many of those species, so we obviously need to get more representative material. But also if we could find associated postcranial, the limb bones that would then be associated with the cranial, the skulls and mandibles of these things, it would then help us to interpret the fossils that we already have and to work out the linkages between them. something like Kenyanthropus from 3.6 million years, we only have that one skull that was found. And it's not a very pretty skull, it's quite expanded. And we've obviously had a bit of criticism about what's been said about it, because some of the skeptics say, oh, it's just you can't say what you're saying from it, although we've done very careful work on it. If we could find more material to drive that home, it would be extremely satisfying. So we need to go out and find more to answer some of those questions that are still quite important. Where did we come from as Homo sapiens, and how and why and when? You know, we can still find a lot more material to fill out this picture that we know so far.
What's so important about limb bones?
Limb bones, it's really you can see and understand a lot about locomotion. There's also a lot of isolated limb bones that you don't know to whom they belong. And so it's questions unanswered. Bipedality, you can see if something was walking on two legs, or how it was walking, or, you know, there's a lot that can actually be understood from the postcrania as well.
I was told to ask you about the scorpions, perhaps you could.
The scorpions, well, where we work, it's very dry. There's a lot of insects which have poison as defense. Scorpions are some of them. And we have solifugids. I don't know if you know about.
I don't know what that is.
They look like spiders, but they're a separate family, and they have very long legs. They're about the size of your hand, and they run extremely fast. They have a very large set of mandibles on which they can catch prey with. And although they're not said to be poisonous, the local people say that if you get bitten by these things, that you talk goat, because you don't make any sense with what you're saying. So we have solifugids and scorpions, and there's a lot of snakes that you have to be very careful with at night, particularly saw-scale vipers, which are highly poisonous, and they rub their scales together, and so you often hear them before you see them because they're so camouflaged. So all of these things are sort of in the background, and you need to be aware of and careful with when you're working in the field.
Anybody been bitten by any of these things over the years?
Certainly have, and survived them. You'd be happy to know, but they certainly do get you occasionally, but only if you stand on them.
Do you carry antivenom or
we
that
have
sort of thing with you?
We have antivenom with us, but you have to refrigerate it, so you have to keep it in an area where you've got a fridge. And you don't administer this generally, but if someone were to get bitten, you would send them to hospital with this in hand so that they could then be dealt with by a professional, because it is quite dangerous to administer antivenom if you don't know what you're doing.
Oh, really? And I suppose you would send them to hospital by airplane?
By airplane, and probably to Nairobi, so a little way away. And you'd need to get them to airlift them out, because by road it's not realistic that you could get somebody in intact. But you'd have to deal with first aid for snake bites, and you need to know what to do on the ground.
And these things that look like the size of your hand that run very fast,
solifugids,
yes, the mandibles and such, what are they looking for?
They're just looking for other insects or possibly small geckos, lizards to eat, and so they come out at night. And when you see one, there's often another one. One of the few things that make you tuck your legs up or stand on a table. They look quite frightening.
What sort of tents do you have? Are these large tents, small tents?
We have a range of different tents. We have small tents for mobile camps when we need to get moving and go to places for smaller periods of time, and we just need to put up a small tent as a store. You can actually sleep out under the stars, and most of us do, because it's so hot at night. And you find a small bush for protection from the wind, and somewhere where you can tie up a mosquito net, because we do have mosquitoes, especially after the rains up there. But big tents for storing fossils, and now we need to run computer equipment every evening. So it's because we've gone more towards technology and helping us, we then have to have all this facility to download data and recharge things and all the rest. So it's grown in size.
It means a lot of generators, I gather.
We have solar panels which charge batteries and have an inverter, so we can actually run computers directly off a power supply.
So you're not running generators?
Not in our field camps, but at the base camp where we run an operation where we have a desalination plant to actually purify the lake water for drinking and things. We have obviously more equipment at base.
And you can run you get enough solar power to run a refrigerator?
We can run, exactly, we can run refrigerators off the solar power, or we use a gas refrigerator, and you bring up gas cylinders from Nairobi to run refrigerators as well.
Oh, propane gas.
Propane
kind of thing.
gas, that's right. I forget you call fuel gas, yes.
Fuel gas. Are there? You mentioned some of the questions that remain unanswered that you're interested in getting answered. Do you have a sense of the pace that these questions are being answered? Is it picking up? Are these answers that are likely to come in a shorter period of time?
I think nowadays there's so many more people working in this field in so many different places that yes, there's an awful lot more information that is being added to the picture. So you've got people working in Indonesia, in China, in Africa. You've got people working in Malawi. You've got them in Chad. You've got them in Niger. You've got them in Tanzania. Everywhere. So it's many more teams involved, and so it's filling up the picture considerably faster, which is exciting.
What are you looking for in Indonesia that you're not looking for in one of the African countries?
Well, in Indonesia, the finds are post 1.8 million years typically, because Homo erectus was the first hominid to leave Africa. Mm-hmm. This is talking about more recent times. Obviously, people are interested in dinosaurs and everything else that goes further back. But so you're looking at Homo erectus or later in terms of the spread of humanity across the rest of the world.
And you're trying to find out when they arrived in Indonesia from Africa? Well,
that, and also just see what the different things, what they were doing. I mean, there's been a recent and a very exciting find from the island of Flores, where you've got a small, either a dwarfed Homo erectus or a dwarfed Homo sapiens, and there's still a lot of discussion about what this actually is. But fantastic find where some species of hominid was isolated on an island for a significantly long amount of time that it became a dwarf. It was dwarfed. It was very small. So things like that, which you wouldn't have imagined, and it was they were there for until maybe 40,000 years ago. So they were living alongside modern humans, but in an isolated context. So those sort of things are very exciting, and other people are working on them and finding the evidence. So it's bringing a much more real picture.
But there's no scientific question at this point that we originated in Africa.
It's 99.9% sure that we originated in Africa. So it's as good as written in stone, both as Homo sapiens and in terms of our earlier origins as well. Okay. And so there's a lot of work towards that, and particularly people working now on some of the DNA evidence showing that Homo sapiens had an African origin and the spread of Homo sapiens across the globe.
How much is known about how the spread took place, how this migration occurred?
Well, they're filling in a lot of this. Again, it's not my line of work exactly, but they, especially now, some of the work done by Spencer Wells and National Geographic Society with the Genographic project, where they're able to take swabs from people across the world, cheek swabs, and actually look at DNA and tell you which population of Homo sapiens you most recently came from and how that ties into the spread of Homo sapiens across the globe. I think that's a very exciting project that's ongoing, and a lot of information about that online, and it has been going on for a few years and will continue to do so.
So even now DNA is beginning
it's beginning to play a very much more important role in our interpretation of things.
Tell me about the Kubifora research project.
Kubifora research project was a project initiated by my parents. 1968, they first went up to Lake Turkana and started to work and explore the eastern shores. It was called the Kubifora Research Project in those days, and it's a continuation of what was done then by a small team of people. And so we've kept the name on today, but that group of scientists who were affiliated with the research project at that time, working with my parents, and the fossil hunters then, some of their sons we work with today. And it's sort of a family that have been working, family in the broader context, working on the east side and the west side of Lake Turkana over the past 35 or so years. So a lot of work has been done on the paleontology, and geologists have been tied to that project. Archaeologists have come and gone from that project, and so it's a long-term project and continues to do that. Now how that ties into the Turkana Basin Institute today, we are one of other projects that will be part of the Turkana Basin Institute, which is affiliated or under Stony Brook at the moment.
It seems to be a pretty large business that the Leakeys have started here and growing all the time.
It's the Leakeys started, but have got a lot more people than Leakeys involved with today, and obviously they're not. I'm married now. There are not too many Leakeys that are going. We were all girls. There are not too many more Leakeys involved, and I think that it's now not a leaky. It's not a leaky game, but there are so many more people taking this science forward. A lot of very well trained, educated, bright Kenyans actually steering their own research projects in the Turkana Basin, who are able to use some of the resources, the facilities that are then now available then to take this forward as well. So it's a long-term research project focused in the Turkana Basin. That its name is taken from Kubifora, which was the base camp on the east side of the lake that was created from 1968 and throughout the 70s.
You said it's not a leaky game, but certainly the Leakey name is something that has attracted so many scientists, so much expertise to this. It's something that is really sort of I would say the driving force behind most, if not all, of this that's going on there now.
That's right. Well, with my grandparents and their early discoveries of Zinjanthropus in Tanzania, and then my father and mother's work at Lake Turkana, they certainly dominated the field in terms of major announcements for many years. But there have been so many more people and major discoveries elsewhere now. So I certainly don't see that as being a leaky thing anymore. It's a much bigger field. But for Turkana, per se, certainly that's where we've certainly dominated that field there for a while, because we've been some of the sole people working there.
Are there any major announcements in the works now?
We'll have to see about that. We always hope there's something in the bag, but I'm not going to spill any beans.
Well, that's what I'm. Are there beans to be spilled?
There might be beans to be spilled.
And if there were beans to be spilled, when would they be spilled?
They take a long time to work on these beans. Let's just say it that way.
How long does it take?
It depends on the find, and if one can actually get descriptions done, and before one actually makes major announcements. And we try to go out every year and spend 3 or so months, or sometimes 2 field seasons, if weather permitting, to actually find new fossils. Now, every year we find 5, 6, 7 hominid remains, but not all of them are big skulls with exciting things to say about them, but they all have to be worked on and described and published in major journals, or certainly journals that people can access.
You said that to get descriptions done. What does that mean?
Well, you have a fossil in a drawer, and you need to know what it is, and it needs to be described and compared to other material. Scientifically. And
what would that description
look like? So that
people
then, it's in a scientific journal, it would describe tooth shape, the tooth size, how it refers to other fossils from other places, and how it fits into the bigger picture. And so those are traditionally what anatomists would actually get involved. But you can't write a paper necessarily about the tooth, so we'd then pool material and put a paper together that would then describe a lot of finds that then other people can then refer to that journal. That's just how it works.
And this is a process that takes a significant amount of time.
It can take a lot of time. Depends on what the find is, again. But it's not just hominids that we find, it's also turtles, it's hippos, it's elephants and pigs, and there's, some of the beautiful pig skulls are, they warrant a publication in itself, and so you involve scientists who are interested in that and actually maybe would do the descriptions and publish those finds as well. It's important to remember that there are so many other species that were coexisting at any one time, and what the context that humans evolved in.
What they were at what particular
they were
time,
eating,
how they interacted.
Exactly. So it is as important and as interesting to collect and all these other things so that we can interpret the habitats and the surrounding environments.
Do you anticipate a fourth generation of paleoanthropologists?
We've got a hard match to follow. I don't think so, no.
No?
I have 2 little girls at the moment, but I'm not sure if my cousins or certainly I'm sure my sisters probably won't get into it. Who knows? You can't actually predict it, but my girls certainly have been up with me up at Lake Turkana, and they're still very young. And we'll have to see. Who can tell?
You said certainly your sisters won't. So they came up in the same environment
They
you
did, but she's not doing that, and so they're not exposed to that lifestyle, so it's less likely. Let's say it's less likely, it's certainly not. And also she needs yet to have children.
It must be a little bit intimidating trying to fill those footsteps.
Those footsteps, yeah. So my father was, because he's had so many different careers, he's been involved in the fossils and the wildlife, and he's been involved in politics, and he's had a plane crash and he's lost his legs below the knees, and he's had kidney transplants, and you can't complain in front of my father because he's had too much else happen to him, so you just sort of buck up and stop whinging and get on with things.
What's whinging?
Whinging is whining, complaining.
He seems to stand up for what he believes, your father.
That's right. So he's got high principled, and so he's taught us well.
Dr. Louise Leakey, thank you very much.
Thank you very much, too.